In this particular session, we are going to discuss the important models, because in the earlier several sessions we have focused much onto our life cycle models and what kind of models our different practitioners they have put up time and again, and even still they are also even putting up in the industry today. So there are some more important models which certainly I would like you to be aware of. And one of the models in that series that is left to be discussed, that is the first when spiral model. As I already had indicated briefly, that our when spiral life cycle model, it is aimed primarily at the stakeholders. And this particular, why it is called when spiral model, because it is based on even this management theory, and that is also called the winning theory. And what we want all the customers and the clients, which are the real stakeholders of any software system, we need to meet out all the requirements. So what we do differently in case of your when spiral model, we saw 4 quadrants in case of spiral model, whereas in this particular model there would be 3 more quadrants in addition to that. And what these 3 additional quadrants are mainly dedicated at, we need to identify the stakeholders in the first quadrant. Then we do find even their win-win conditions, and the third, we reconcile their win-win conditions by the mutual discussion and deliberations. So with these 3 new additions to our original spiral life cycle model, is nothing but it is your when spiral life cycle model. And let's have a look at that what exactly this model is aimed at. It is based on making winners of all the system's key stakeholders as a necessary and sufficient condition for project success. It's nothing but we need to do, first thing, that we need to identify the system stakeholders and their win conditions. Second to this, we must reconcile win conditions through negotiation to arrive at a mutually satisfactory set of objectives, constraints, and alternatives for the next level. And this is how we do come across even a refined and upgraded our spiral life cycle model, because at the top of our spiral life cycle model, we also even refine with 3 more major quadrants, and which are aimed, if you just do look in this diagram, the 3 even quadrants which are scattered over this gray background, this is the new addition in your when spiral life cycle model. And the first quadrant is dedicated for what purpose? On identification of the next level stakeholders. It means we certainly need to identify even the different stakeholders, even that too, even across our different spirals. Next, we have to identify stakeholders win conditions. What are the win conditions for the individual stakeholder? And the third, we reconcile these win conditions. After this reconciliation of the winning conditions, then we also even establish next level objectives. And here how we even move up onto even the other 4 quadrants. That is, we evaluate the product and our process alternatives and resolve different risks. Then we define next level of product and process. Then we move on to what validation of the activity, and at the last we look at the review and our this commitment. So in the nutshell, in our win-win spiral life cycle model, we have even our three enhancements, and the three enhancements are subjected to what? Primarily focused on to even the individual stakeholders. We do take up one stakeholder. Now for that stakeholder, what are the winning conditions? So the particular stakeholder and their winning conditions, these are subjected to what? Reconciliation. And reconciliation of the winning conditions, these are even mutually negotiated and finally struck, so that we can lay down even the different objectives. We even enumerate the constraints, so that even our next level design and development may proceed. If we look at the center of any spiral model, whether it is your win-win, or it is your Bohem spiral model, or it is its full spiral model, or its other variation of the spiral model, we look at the center, how we are moving from the first quadrant. We are just moving out and out like this. So moving from the beginning point and reaching up to the last point, it could be staying anywhere in the quadrant. What we do witness, we find a big variation. Variation amounts to what? Our different degrees of your software development. Whether it could be the individual prototypes, whether it could be even different kinds of risk assessment and mitigations, whether it could be individual constraints that we do come across in the initial stage or the outer stages. So in general, what exactly we had in the earlier spiral life cycle model, here we do focus primarily on to our clients, our customers, whom we consider as what? As the key stakeholders. As a developer, I am also the key stakeholder. As a client, you could also be what? Our stakeholders. So what we do is, for everybody, whosoever is the key stakeholder, we strike at the win conditions. We enumerate the win-win conditions, and then what? We do establish even the objectives as what one wants, that so that one can be even put to what? Our winning condition. So we want everyone to be happy with their own requirements. They wanted it should be fulfilled. So that should be the true spirit of even thorough involvement onto our software production. If we do look as to where this spiral model would exactly fit into, these are nothing but these are the different even steps that we need to undertake as a part of it. If we just do look and just go through our systematically, first thing here we find identifying the stakeholders, again win-win conditions, then what? Even evaluation of the product. So it means the first two steps what we have, identifying the system stakeholders and their win conditions. Second to this is reconciling win condition through negotiation to arrive at a mutually satisfactory set of objectives. Here look at this mutually satisfactory set of objectives, constraints and alternatives, because this was the first step of even setting objectives, constraints and alternatives in case of our Bohem's spiral life cycle model. Next, even quadrant that is dedicated for what? Evaluation of the product and process alternatives, resolve different risks all through the different spirals, and then we enter into the next quadrant, and that is your fifth quadrant, and that is define next level of product and process including partitions. And then we move on to this validation of the product and the process definitions. And finally, we go for what? Our review and the commitment of even our software development process activities. So in general, when you do coin the commencement or the beginning of your life cycle model, up till the point of what our functional system that you obtained at the end of your spiral process, then what we do talk of the maintenance. And when our maintenance is also not even cost effective, and it doesn't come out to be more fruitful while striking at the total cost incurred onto the process, then we normally do consider that it is the right time for the software system to be retired. So that is the even crux, that as to how that we need to look at the different process models. If we move further, that it is not the end of the life cycle models. Time and again, and from time to time, we do keep witnessing the arrival of more and more subsequent models. Another model in the series that came across, that was object oriented life cycle model. But before we proceed on to the discussion of the object oriented life cycle model, I would certainly like to address our dear students regarding that as to how we perceive or view the philosophy of object oriented design. What we mean by an object, what exactly are the classes, how we are moving from what function oriented languages to what even object oriented languages. Everyone could be rushing after even adoption of our object oriented languages, object oriented programming, object oriented designing. It could be what even more our different kind of your analogy which are taken and addressed onto that. So how we define what exactly would be the different stages of our object oriented life cycle model. If you do look systematically, that what should be there in case of your object oriented life cycle model, because it would require, it is a development which employs an object oriented strategy, and this object oriented strategy, it really geared up even the early 90s. And more so, what were the primary objectives of our this particular model? That it involved our three major activities as a part of this process. And the first is what? Object oriented analysis, object oriented design, and object oriented programming. You might be wondering that when we say even the arrival of object oriented characterization even in the process, how it may come to even impact and influence even the progression of the activities all across. I'll set one example for that. If I'm more interested in designing any software, and the nature of the software that could be even nothing but similar to some of the earlier softwares developed and delivered. Now, as an experienced hand on to similar projects, what do you think? Am I not going to consider my early experience and my earlier software stuff into the new project? As a practitioner, as a software developer, I certainly would like to seek even the support from our early experience. But our question is, up to what percentage our this reusability would help? Because how our this software systems have evolved, and how from even our that precision oriented languages even to what object oriented and our .NET languages, how we have evolved across. So it means there was a time then when you used to have our even modern programming languages which were nothing beyond our function oriented and object oriented language. But this is not the only scene that is going to stop at this point, but rather it will be going ahead further, because we have started talking of what? Component based languages, component based systems. What do you think? Is the approach altogether different? May not be, but in true terms we have to perceive it in its own ways and style. Let me say, if I am talking about, like, this is a pen, it's nothing but it's hardware that we can use, that it is meant for writing. But how we do look at our this pen, it could be perceived it is a cap. If we do perceive it's pen nozzle, if you do look, if you just take it out, it can be even taken out of this. So what we do perceive, nothing but in our this pen, what we have its different components. Now the question is, in its components, is it necessary that we do produce even all the components separately? If the manufacturer has to produce the pen, do we need to even strike the first activity to produce the cap, to produce even the refill, or it could be even the other different components? Not necessary, but rather thinking on, because being what? Being an hardware. Now is it possible that in case of your software, which unlike this is invisible, because software we can't see. If we can't see, then how we can plan to develop it is a big challenge. How we can control it, another challenge. How we can schedule and monitor, again quite difficult. So software project management, it is not so easy a job. It is full of challenges. But no doubt, whatever the early experience of our practitioners has encouraged from time to time, we are also progressing on that path. And even what you are practicing today, tomorrow it will be quite helpful for the coming generations, that how our software development was existing at the early times. So my summation is that our style of programming, style of development, analogy, our strategies, our philosophies, our methodologies, these keep changing. And so is the case for what? For our object oriented languages. And if you do look how it appears to be, now let's have a look at, spend some time onto this diagram. This is our object oriented lifecycle model, and if you do look, our this gray color box, it contains implementation and documentation. But do start from the beginning phase, that the requirement analysis. This is your system specification, this is your design, this is your planning, this is your implementation, this is your testing. Now if you do look very carefully, when you do find its planning, when you do look at its use, what exactly it is? This is nothing but this is your complete class library. This class library that you, after even testing, you do put up, and after testing you also implement it. So what my summation is, that looking at our object oriented lifecycle model, that in case of this class box, we do maintain even your tested classes. How we were encouraged to develop, to document, to implement. This is nothing but this is the even arrows which are indicating. These are the different arrows. It means what you do. These even classes, they even encourage you to plan, and this planning really help to what? To contribute to this design. Similarly, when you are talking about after you could test, and even this, our some tests were introduced, and what even different classes were ready, what you did, they were put to use, and these were finally helped in implementation. And this is how ultimately we'll be going further. For example, at the last, when you have come up with your complete, that is your operational system, and operational system that is too designed with what, with our different classes, methods, processes, procedures, but that is all have been even amended or have been tuned to what, our object oriented philosophy. Only then we could receive this kind of treatment in case of your object oriented system design. So starting, it means it will be even a different kind of thought or process or a culture. So it's not possible so easily that once you are habitual of programming on function oriented languages, you can easily switch to what, object oriented languages, object oriented design. It is so new a philosophy. At the moment it is not so new, but it came in the early 90s, I would say. But with its arrival and with its intended benefits, it has left a strong influence, and people got motivated, and they also even put up full-fledged solution for all kind of nature of your different software artifacts. So these were the crux of your software development lifecycle model. If you do look, what exactly were our other lifecycle models, people were also encouraged. Have a look at that. In case of your object oriented lifecycle models, even still we are witnessing more and more newer models. One of very popular model, fountain model, and this fountain model, it was introduced by Henderson, Seller, Edwards in 1990. Similarly, recursive and parallel lifecycle model, it was introduced by Brad in the year 93. Similarly, very important, another model, unified software development process, it was introduced by Jacob, Boch and Rambach. So what my summation is, that we should not be restricted alone to 1, 2, 3 or 4 models, but rather we should look into the very nature of our changing requirements, the very nature of what, of even existing infrastructure, our individual skilled hands, and the nature of the product that is to be engineered. So in order to best engineer a product, we certainly must think and also adapt to the newer and newer philosophy for design. Now I'll be just taking you to what, to a very fantastic model out of these, and that is nothing but even your fountain model. Do look on to this fountain model, which was introduced by Henderson. What do we find here? Let's look at the notation. Our circles, they're indicating your phases. Our overlapping of our several circles, it indicates parallelism. And you might be witnessing and looking at our arrows, they do indicate even the iteration. And maybe in comparison to larger circles, even small circles, they do indicate even your maintenance circles. So if you just make a systematic go through of your this particular model, look for, we just move from here, from the bottom, and what we saw, this was nothing but our these arrows are falling on the outer side, and it's nothing but, it's just like a fountain. How the fountain, even water from the fountain is poured in all different directions, and that's why it made to call it what is a kind of your even fountain model. We do start from commence with what, our requirement specification, and in case of requirement specification, what we are doing, we are just moving out, and that's why looking up, even this circle, this your circle, even within this circle this is a movement, and this is the arrow on the left and this right side. We move on to next, it will be, it means overlapping. And what is the activity meant for? it will be some kind of your object oriented analysis phase, so that even that phase is also encouraged to adopt our object oriented characterization in your this design. Then we move on to what? Object oriented design, and how we even overlap the other activities, including implementation phase and your implementation and integration phase. These all three have been even overlapped. So it means it is not necessary that your specific even iteration would be altogether separated, but rather they could certainly be overlapped. It means if I am saying that I have to finish from this to this point, it's not necessary that will be starting from here at the top, but rather there could also be some parallel activities that may be undertaken. And same is the case that has been followed in case of our fountain model. It has been embedded with our this object oriented approach for even analysis, for our design, for our integration, for our implementation, and at the last even for what? For even further development. Because our object oriented philosophy, it is not targeted only for even your existing development, but rather it is a kind of development that really help for what? Future. There are two kinds of development: development with reuse and development for reuse. With reuse in the sense, whatever we have half-heartedly we have developed so far, we can enjoy benefits from our early creations, but it is because the early creation of our software system, they were not targeted to be reused for a long time. But bringing a different kind of culture in your software development and targeting, okay, today what you are going to create and produce, you are not only meeting your present requirements, but rather you are even targeting your one eye at the future too. That's why that you are not developing with reuse, you are developing for reuse. It means you are targeting high, and you are just intending to even maximize your reusability of our different methods, different classes, different processes, so that whenever the opportunity comes for our newer projects, you can hand even those even selected procedures, even classes, your designs, and you do adopt in case of your newer projects. What does it do? It helps a lot, because it is easier to produce. It is even also minimizing your testing efforts. Also, it is not necessary to even produce afresh, starting out its development from scratch, but rather you can build onto your component based system with our early reusable components and your reusable stuff. And same is the case here what we are discussing. So that's why finally have a look at your once again onto this fountain model. What do we find in this particular model? Here at the last, this your operational model, these are the operations, and here the further development. So starting from here where we moved, we started from requirement phase, passing through object oriented analysis phase, moving on to object oriented design phase, moving on to implementation phase, then for integration phase, then for operations mode, and then to what? Further development. This is how we even subsequently working on to many other models. In the series, there is one more important model to be discussed, and that is what? That is a mix-up of the two. And this mix-up is of nothing but the two important even specific models we so far have discussed, and that is prototyping lifecycle models, and the one recently discussed just now, it was our object oriented lifecycle model. That's why a mixed blend sometimes is also called prototyping and object oriented lifecycle model. So it means we are targeting even the beauties of both the models in one model. It means two in one model. Whereas if we do recollect, in case of spiral life cycle model, what we saw, there were many in one model. Here we are even targeting, we are just narrowing our focus, that we are interested to what, hybridize our life cycle model with the two ingredients, and those two ingredients include prototyping and your object oriented characterization. Now let's make a study of this model, that how it is new. Look at initial, that these are the requirements, and initial is a user interface design. Here is the prototyping, here is the user interface classes, and on this side with the requirements, it is your design of functional parts. Here is user interface, and here is function oriented classes, and we both of these are integrated, and then we move on to the prototype, and then we move on to our test and implementation. Now what did you observe in this particular model? We are targeting at one hand, that is how we evolved with our user interface. At the same time, we are talking about the evolution of what, of your functionality. So it means the two things taken together, whether it's your user interface design or it could be functionality, and that too, what it comes, we are not even reaching to the design in a single go, but rather we are inherently following the approach all through our different prototypes. So it means even this particular arrow in the, that's your middle quadrant of this section, integration of these two processes into prototype and its testing and validation. What do we do find? If our requirements are complete, these are finally even laid down for our final functional model or functional system, only then it would be allowed to be integrated. Otherwise, whether it could be the prototyping of the requirements and the prototyping of the user interface, both would go hand in hand. And this is how our different software system development approaches are fantastic and are artistic in nature. If we move on to further, the best, even the advantageous part of the discussion on to our life cycle models would be finally aimed at as which model to follow, because so far that you already have gone through even around a dozens of models, because you might be having a certain confusion in mind as to which model I should follow. I'll be simply telling one thing in crux, in the nutshell. No single model is going to help you in all situations. We should not rely, we should not need not to stick to only and only model, because we need to even learn or just judge the nerve of our specific project at hand. That's why I'm simply just in the nutshell I'm going to share with you that how we decide the choice or the stability of a model, and particularly which models. I'm just going to ponder on to only the stability of those models which have been even earmarked quite important models all through our last 5-6 decades. And have a look for the first, the waterfall model. When the waterfall life cycle model is stable for us, when our requirements have already been frozen, but it is beautiful for what? For budgeting. At the same time, if you do look where we should follow our iterative life cycle model, iterative life cycle models should be followed only in the instances where you can't wait in the beginning to have the complete populated requirements so that we can commence with its overall development. And what subsequently we do, we come up with our different iterations. So it means our different supplements or different increments. It means maybe you can say out of your total n requirements, you are taking 5 in the beginning, 4 in the next, 10 in the next, and in this manner you subsequently achieve all the n requirements. But what steps you need to undertake for even 5 requirements or for 3 requirements? So in this way you also have to follow the same span of your waterfall life cycle model. So let me enumerate and you please go through as to how we are just going to talk about how for which particular model these are good. Iterative models do attempt to solve this by coding. It means coding is important for these kind of models, and where we can even take up our different iterations. When we move on to what our spiral models and win-win spiral models. Spiral model I already have discussed at depth, and so far you certainly would have been able to what identify as yes, that is the best choice in the cases where we need to address all the different risks at each and every stage. In case of if we properly and appropriately address all the risks, then even prototyping, even your iterations, even your increments, that would also remain. They would also remain as even as a part of our this spiral life cycle model itself. But where we would plan to apply win-win spiral models, when we are more keen and even more concerned about even each of our stakeholders. And that's why, because our these 3 aspects that we discussed in the initial of our session, that is those 3 aspects of the key stakeholders are undertaken as a part of this. So friends, this is about all of our complete our life cycle models. Next to that, very important aspect I am going to take up next, and that is your currently quite popular, and people are very specific about whether one is aware of or not, and that is nothing but your agile software development. Friends, agile software development is nothing but it is those kind of your development approaches which encourages us so as we can adopt better ways of development of software by doing it as well as by helping others to do it. So it means it's not doing yourself, but rather it will be motivating others to complete. So what we do, we are nothing but as a part of your agile software development, we certainly should not be restricted of our own, but rather we must focus on to all those approaches which can really help us. I'll just make you understand through this diagram, because this is all put up by our different researchers and our practitioners. Just spending a minute onto this, what we do, because here we start from our development, then your iteration, then incremental release, and that's your product design. What we are doing it, we are developing it hurriedly, but in increments. And what we are doing, we are just nothing but we are simply starting with the initial development quickly. We test it, we design it, then we follow what even next iteration, then we evaluate too, then we also move for incremental release, and then we what move on to the complete functionality of the product. So what we saw in our agile software development, we are to focus on to any approach, any technique, any philosophy which can help even to develop the product quickly. And there's another aspect another even big concern, that is called extreme programming. Extreme programming practices is also a part of the same agile software development. So certainly you need to learn and know about your agile software development. So friends, today we just conclude to our all life cycle models with a twist to our new philosophy, and that I would say is the philosophy for the even coming generations, that is your agile software development. Thank you very much.